How's it going, you guys? We are on variance and standard deviation. This is day 6 of our 8-day long unit over stats, and so we've got 2 videos left after this. But variance and standard deviation, this is measuring spread. It's a type of way to measure how spread out your data is from each other. And so a couple different measures of spread that we've already talked about are the range. Remember, that's the maximum number minus the minimum number. And the IQR. Remember, that's Q3 minus Q1. And those two things measure how spread out your data is, but also variance and standard deviation measure how spread out your data is. And so that's what this section is over. I've got a couple vocab words for you to copy down. What I want you to really focus on here is the formula for variance. And it looks kind of crazy if you're not familiar with this symbol. This is a summation symbol, and it means take every single x value and subtract the mean. So figure out how far away every single value in your data set is away from the mean, and then square all of those numbers. Keep in mind, sometimes when you do x minus x bar, remember x bar is a symbol for mean. Sometimes when you subtract a certain value from the mean, if the person is over average, that means when you subtract the average, it's going to be a positive number. If the person or data value, whatever it is below average, that's going to be a negative number. But when you square all of those averages, they're all going to be positive. Then you're supposed to add them all up and then divide by n minus 1. And so what this is right here, I wrote down a little note, the sum of all the squared deviations. And then keep in mind, n is the number of things you have. And so look at how similar the variance formula is to the standard deviation formula. What I want you to note up here in these vocab words that you copied down is that the standard deviation is just the square root of the variance. So this part is the same as this part. So notice I'm using the same letter here, s squared and s. S squared is variance and s is standard deviation. One other thing I want you to make a note about is that the standard deviation has the same units as original data set. So if you're measuring something in feet and you're wanting to know like how tall everyone is, I guess, maybe that would be inches, then your standard deviation is also inches. If it's time it takes you to get to school, your standard deviation is also in time, probably minutes or whatever the units are of the original question. Variance does not have units. So keep that in mind. The reason for that is because it's technically units squared, and usually units squared doesn't make sense in context. So we don't put units on variance. So just keep that in mind. A couple little notes there for you. I'm going to go right into these properties down here. Again, if you missed something or didn't get to copy something down, just pause the video or rewind or whatever. But first of all, the measures of standard deviation, it measures how far the values are from the mean. And so that should only be used when the mean is appropriate to use as the center. So like not if something is heavily skewed. Or lots of outliers. In that case, our standard deviation is not going to be very useful to us because it's going to be thrown off by those outliers or the skew. And so that's what I mean, should only be used when the mean is appropriate to use as the center. Another thing about standard deviation is that it is always positive. The reason for that is because we square a bunch of values in the formula. And so a larger standard deviation means your data is more spread out. If it's a very small standard deviation, that means that all of your values are really compact and close together. If the standard deviation happens to equal 0, that means that it's not spread out from each other at all. So remember that standard deviation is measuring how far away every single value is from the average. And so if the distance from the average to every single data point is 0, that means all the values have to be the same exact value. So if I had a standard deviation of 0 on one of my quizzes or tests in this class, that would mean every single person got the same exact score. That would mean every single person had the average score, all the exact same. Therefore, they are 0 points or percentage points away from the mean. For number 4, just like the mean, it is non-resistant. So those outliers, since the standard deviation is calculated using the mean, the outliers really affect the mean and also the standard deviation. So I'm going to go right into this first example. We have the heights of 5 starters of a basketball team, and these are in inches, so these are their heights. They're already in order, which is nice, but for standard deviation, the values do not need to be in order. That's only for box plots. Make a table below to show each deviation from the mean as well as each squared deviation. So the first thing I need to do is calculate the mean. Remember, that's an X bar is the symbol for that. And you can use your calculator to verify this for me, but the mean of these 5 dudes on the basketball team is 75 inches. And so the first thing I have to do is I'm going to make a table. I have all my different X values, and what I need to do is subtract those from the mean. So that's what I'm going to do first. All 5 of my X values, 67, 72, 76, there's 2 76s, I believe, yep, and 84. So these are all my X values. The next column, what I'm going to do is do all the X values minus the mean, which was 75. 72 minus 75, 76 minus 75. This is how you do your table. The next thing I have to do, and you can just look up at the top of your notes where we have the standard deviation formula, is I need to square all of those values. Okay, so when I do 67 minus 75, that's a difference of -8. That's the deviation, but when I square it, I get 64. So remember, whenever you square a negative number, you get a positive number. So I just filled out that column really quickly, and that gives you all of the squared deviations. That's what these numbers are referred to as. By the way, these are all the squared, because they are squared deviations. Deviation is that word, very first word you wrote at the top that you copied down that definition. It means distance from the mean. So I did all of these deviations, and then I squared them all. And so the next thing I have to do, remember that summation symbol, is I have to add them all up together. So what I'm doing is I am adding this number, this number, this number, this number, and this number, and that gives me 156. You can pause, you can calculate that just to check my math, but when you add all of those numbers up, you get 156. And the last thing I have to do is divide by n minus 1. And there were 5 dudes, so that means I'm dividing by 4. So 156 divided by 4, which gives me 39. And this is my variance. So yeah, it's a little bit of like a tedious process. Remember, variance doesn't have units on it, so it's not inches. Technically, it's like inches squared, but in a weird way, so don't worry about it. We do not label units on variance. Let me just pause and recap what happened here, because this is how you're going to start calculating standard deviation in order to do any of these calculations. What I did first is I calculated all the deviations. That's what these were called. Maybe I'll write this in, deviations. That means just take all of the X values and subtract the mean. And then you have to square all of those deviations, which is how I got these numbers. Notice that they're always positive. That's supposed to be positive because you're squaring either a negative or a positive number. Next, what you have to do is add all those things up. That's the summation symbol that's part of the formula. And when I added them all up, I got 156. Divide by the number of things you have minus 1. I have 5 people here on the basketball team, so dividing by 4 gives me 39, which is the variance. And then the last thing is the standard deviation. So I already got variance here equals 39, see above. I could have written it down here, I guess, no big deal. And now I need to do the standard deviation. So standard deviation equals the square root of the variance, which is the square root of 39. That number happens to be about 6.24 inches. Now it wants me to interpret this standard deviation, what this actually means. And so the standard deviation, remember, it measures how spread out our data is. And what this is this is the average distance away from the mean of all of the heights of the guys. Okay, so I wrote a little sentence for you to copy down what the standard deviation actually means. What this means is on average. This is probably the most important part of the definition, on average. But it means on average, each person's height differs from the mean. Remember, the mean was 75 inches by about this many inches. So it's the average distance away from the average. So it's a lot of using the word average. There are a couple things I need you to keep in mind. The mean in this case, the 75 inches, not one person on the basketball team actually was 75 inches tall. But remember, you guys know what average means. It's if you throw everybody into a hat and divvy up the height all together, every single person is about 75 inches. But look at all the individual values of the heights up here. Not one of them is 75, but you've used average many times in the past. You understand what that 75 means. Also, not every single basketball player is exactly 6.24 inches away from 75. What we did is we took all the distances from the mean, we squared them, and then we did a weird formula, and that measures the standard deviation. So on average, each person's height differs from the mean by about 6.24 inches. That's how we interpret the standard deviation. That's the most important part of this section. Okay, you guys, regarding this next example, all I want you to do is I encourage you to pause the video and see if you can come up with variance and standard deviation of these values quickly. And then tomorrow in class, what I want to do is show you how to get these values in the calculator, and then we will complete the rest of the questions as kind of a class discussion. So just as practice, pause the video. I'm going to show you how to compute these, the variance and the standard deviation. Try and do it without looking at your notes. See how well you can remember the formula, and then just check your answer with mine. So I'm just going to go through this quickly so you can check your math and make sure that you've done the appropriate calculations here. I listed all my x values. Remember, it doesn't matter if you put them in order or not, because all we're doing is adding them up. So, and then I found the mean, which by the way was 84. So this is a sample of AP Stats students on their most recent test. The x bar for just these 7 students was 84%. And remember, x bar means average, it's a symbol. And so you take all of your x values and subtract the x bar from it. And so I wrote those here. All of those deviations are here. Only one of them happened to be negative. This person that was a 60% scored way below average, which gave me a negative deviation. But then remember, when you square them, they all become positive numbers. This person who scored exactly average, they deviated from the mean 0%. So their squared deviation is still 0. When you add up all of these numbers, you get 730, and then divide it by n minus 1, which gives us 6 because there are 7 students. And that means that this is my variance. And I rounded this number just a little bit, so if your calculator gave you something slightly different, that's okay. And then just remember that you square root the variance to get the standard deviation, which is 11.03. And just remember what this 11.03 means. That means that on average, every single person scored about 11% away from the average. So that's kind of a big standard deviation if you consider test scores. You know, the average was 84, but how far away was maybe your score from that 84? 11 points, that's a lot. Okay, and so the point of the rest of the questions here, which we'll get into in class, is what happens if you have maybe a potential outlier here? What happens to our standard deviation? Notice how this is a big number, and I think it's because this outlier really threw it off. Look how big their squared deviation is. So just keep that in mind, and that's the discussion we'll start class with tomorrow. Thank you guys for watching. Have a great night.